Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in.
Okay, we're going to start by looking at some of the questions they could ask you about the ruler drop test. So, a pupil catches the ruler at 15 centimetres, 12 centimetres and 13 centimetres. What is the mean distance? Okay, so what's the mean distance out of these? Well, to find the mean, I just have to add them all together and divide by my number of results. So 15 plus 12 plus 13 divided by 3 is 13.3 recurring centimetres. And now it's asked me to use this information to find the student's reaction time. Now, the ruler drop test is that test where somebody holds the ruler just above your hand, they drop it without you knowing when they're going to drop it, and you catch it in your hand. Okay, and it's a way of measuring our reaction time. So how do we actually use that distance that the ruler drops through to calculate your reaction time? Well, we're going to need to use our SUVAT equations. So what I'm going to do first is write down all the information that we know. So we know that the initial speed of the ruler as it's being dropped is 0. We know that the acceleration of the ruler is just the acceleration due to gravity, which is 10. And we also know the mean distance that the ruler drops through is 13.3 recurring centimetres. So that's written as 0.133 because, of course, we need our distances to be in metres to put them into the equation. So which equation can we use to get ourselves started? Well, here's an equation that uses all three of those variables and only has one missing, and that is the v squared. So I can definitely use this information to find what the final speed of that ruler is going to be once it's dropped. So I'm going to plug all of those variables into the correct parts of my equation, and I get v squared minus 0 squared is 2 times 10 times 0.133. And if I simplify that right-hand side, I get that v squared is 2.66, and therefore v is 1.63. So you might be thinking to yourself, well, that's great, but how is that the reaction time? Because that's the final velocity. Well, I needed to do this step and work out the final velocity so that I had an extra piece of information. Okay, because now if I write out my SUVAT, I have S, U, V and A. So now I have all the stuff that I need to work out my time t. And I'm going to use my other SUVAT equation to do it. V is U plus AT. So I have, putting all of those in the correct places, 1.63 is 0 plus 10 times t. So 1.63 is 10t. And then if I divide through by 10, I get 0.163 is t, my time in seconds. Okay, now to have a little look at a question about the forces involved in crashes. So we have a van crashing for 0.8 seconds. It was travelling through town. Estimate the force on the van. Okay, so as always with these, I'm going to put my equation that I know down first. F is mv minus mu over t. Then I'm going to try and extract as much information as I can from the question. So I'm going to write out all of my different variables. I have my time, 0.8 seconds. I have my final speed is going to be 0 because this thing is crashing, and then we'll eventually come to a stop. And my initial speed, I'm going to say, okay, well, it's traveling through town. So it's going roughly half the speed it would on a motorway, and I know that on a motorway cars go at 25 meters per second. That's something you need to learn. So I'm going to say that maybe its initial speed was 12.5 meters per second. And since it's a van and not a car, I'm going to say that it's probably between 1.5 and double times the mass of a car. So I'm going to say it's roughly 2,000 kilograms. Okay, and there will be ample leeway in your exam for these estimations. So now I'm just going to plug all of those into my equation. F is 2,000 times 0 minus 2,000 times 12.5 divided by 0.8, and you have your force is 31,250 newtons. Okay, now looking at some thinking distance, so estimating the thinking distance of a car travelling through town. So I need to know what equation I'm using, and I am of course using speed equals distance over time, or if I rearrange it for what I need, which is my distance is my speed multiplied by my time. Okay, so what is my speed and my time? Well, just as in the previous example, I have an argument for saying when the car's travelling through town that the speed should be roughly 12.5 meters per second, and the time is going to be the person's reaction time. So that can be anywhere between 0.2 and 0.5 seconds. So I've just chosen 0.2 in this example here. And I know it's the reaction time because remember, your thinking distance is the distance you travel whilst you are thinking about you've seen the hazard and before you apply the brakes. So distance is 12.5 times 0.2 is 2.5 meters. Okay, next we're looking at calculating our braking distance. So estimating the braking distance of a car travelling through town, knowing the force due to the brakes is 7,500 newtons. Okay, so when a car is travelling along the road, it has a lot of kinetic energy, and as you apply the brakes and the car comes to a stop, that kinetic energy is transferred into heat energy. Okay, and the process by which that energy is transferred is via your brakes braking over a distance. Okay, and we call that the work done. So in other words, the kinetic energy that your car starts with is going to be equal to the work done by that braking force over that distance it takes for your car to stop. So I have my equation for kinetic energy, half times mass times velocity squared, is equal to my equation for work done, braking force times distance. And what information do I have in my question? Well, I've got the speed because it's travelling through town. So again, I'm going to argue 12.5 meters per second. I've got the mass of the car, 1,000 kilograms, and I've got the braking force, 7,500 newtons. So let me plug those variables into the correct part of my equation. Half times 1,000 times 12.5 squared is 7,500 times the distance. So let me first simplify that left-hand side, plugging it all into my calculator. 78,125 equals 7,500 times my distance. If I divide through by 7,500, I'll get my distance on its own, and that is 10.4 meters. Okay, now to look at stopping distances. So below shows thinking and braking distances for a car at certain speeds. Fill in the missing ones. So let's start by looking at our thinking distance. And for this, I'm going to use the idea of a factor. So in order to do this, I look at the fact that for 10 meters per second, my thinking distance is 2 meters. If I want to know what happens when I go from 10 meters per second to 25 meters per second, the first thing I need to do is work out by what factor has my speed changed. So if I take 25 and divide it by 10, that gives me a factor of 2.5, or I'm going 2.5 times as quickly as I was when my thinking distance was 2 meters. Now, for a thinking distance, all you need to do is take that factor you've just calculated and multiply it by the original distance. So 2 meters times 2.5 is 5 meters if you're traveling 25 meters per second. Okay, and the reason for that is that your reaction time remains the same. So the only thing that affects your thinking distance is the speed that you're going, and it's directly proportional to that speed. Okay, let's do it for 10 to 40 meters per second. So this time my factor is 40 divided by 10, and that is a factor of 4. So I'll multiply my original thinking distance 2 by 4, and that gives me 8 meters for my thinking distance there. Okay, let's go on and have a look at my braking distance now. So we're going to start in a very similar fashion. Okay, we are going to go, my braking distance at 40 meters per second is 150, and I want to know what it's going to be at 25 meters per second. So I'm going to find the factor first. So final one, 25 divided by 40 is 0.625. Okay, so that is the factor that my speed is reduced by. This time, instead of just multiplying 150 by that factor, I first need to square my factor. Okay, I'll talk about in a second why you square it. So square the factor, then multiply your original distance, 150, by that factor to get 58.6. Okay, let's quickly do it for the next one. Going from 40 to 10 for braking, well, my factor is 10 over 40, which is a quarter. Then I need to square that factor. Then I need to multiply the original distance by that factor, and I get 9.4 meters. And the reason I need to square these factors here is because your braking distance doesn't depend just on your velocity. It's actually directly proportional to your velocity squared. And the reason for that is because your braking distance is affected by your kinetic energy. And the kinetic energy has that v squared term in your equation. Okay, if I wanted to find the stopping distance for each of these speeds, then I'd simply add the thinking and braking together. So for example, at 10 meters per second, it would be 2 plus 9.4 is 11.4 meters. Okay, moving on to some explanation questions. So for example, they could present you with the ruler drop experiment and ask you to explain the disadvantages of that kind of test. The first one is the accuracy, or being accurate with this is actually quite difficult. You would find if you did this experimentally, you'd get quite a large range of different readings, and it's hard to be very precise because it's not always obvious exactly where your fingers have lined up with your little millimeter dashes on your ruler. So that's difficult. And the other thing is, of course, we take the acceleration of your ruler to be 10, but realistically there will be some air resistance acting on your ruler as well, which might reduce that acceleration downwards. Explain factors affecting the ruler drop test. Well, you would find if you were to do it in a noisy classroom, there'd be a lot of distractions. You'd probably get longer distances because you'd have a longer reaction time. Or let's say you were tired and your reaction time was longer as well, could affect your results. Okay, and some explanation style questions for stopping distance. Explain in which ways icy roads affect stopping distance. So they are going to affect your braking distance in particular because you have less friction between the car and the road, and so your braking force that you would be able to apply would be reduced, and you would have a longer, therefore, braking distance. It wouldn't affect your thinking distance because your thinking distance just depends on the speed and your reaction time, okay, which icy roads don't affect. Explain in which ways poor visibility affects stopping distance. Now, this is a common misconception because people often write down weather as their idea for something affecting your stopping distance of your car, and that can be true, as we just seen with the icy roads. But visibility doesn't technically affect either your thinking or your braking distance, okay? It's true that things are harder to see when the visibility is poor, but still, once you've seen the hazard, your time to react would be the same and your time to stop would be the same. The reason it's more dangerous to be driving in poor visibility is, of course, because you actually end up being closer to things before you even see them. So before you even begin the stopping process, which means you have less distance to play with then when you do want to come to a stop. So yeah, it doesn't affect it, but it does have a different implication for safety. State and explain how speed affects stopping distances in detail. So speed is directly proportional to your thinking distance, and speed squared is directly proportional to your braking distance. So that's how it affects your overall stopping distance.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, tips and tricks for these questions. First one is, be careful with weather. I wouldn't avoid writing any kind of thing alluding to visibility being the problem, but keep to things that are reducing the amount of friction between the car and the surface. So that's ice or snow or rain. And then check for sensible answers. If your braking distance is roughly 50 meters, that seems quite sensible. If you come up with a braking distance between 2 meters, when your car is traveling at 30 meters per second, that's not sensible, and you may have made a mistake somewhere in your calculation. Another one I just want to quickly add to this actually is when you're using that forces mv minus mu over t equation, is to plug into your calculator m times v, plug in your calculator m times u, and actually do that sum first, that mv minus mu, and then divide it all by t. You can put loads of brackets in your calculator, but if you don't put brackets in the right place, then you may make a mistake with that calculation. So in order to simplify that, I would do that to double check your answers.